Okay, here we are continuing Unit 3. Continuing our Unit 3, and this is Lesson 3. Lesson 3 is about simplifying radicals and then using that information to help us solve quadratics using square roots if we can. One way to solve quadratics is factoring. Another way sometimes if we can get the x squared all by itself, we don't have an x term, we can use square roots. But before we get there, we have to remember what radicals do and how we simplify them. So first of all, a radical is any expression with a square root, cube root, etc. Remember, the radical symbol looks like this. We're going to list the first 20 perfect squares. So a square root, remember, is something times itself. So 1 times 1 is 1. That's our first perfect square. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 25. 6 times 6 is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81, 10 squared is 100, 11 squared, 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225. We're going to continue on, 256, 289, 824, sorry, 324, not 824, 324, 361, and 400, which is 20 squared. Okay, so when we're simplifying radicals, there are 2 different cases. Either you have a perfect square inside of the radical, one of these numbers, or you have a non-perfect square. If you have a perfect square, you're just going to take the square root of that number. There's a square root button on your calculator. We're going to take the square root of that number. Or you have some of them memorized. Non-perfect squares, when we're looking at the second case, when you have a non-perfect square, we have to break that radical down. We're going to break it down by dividing it into its factors. And one of the factors should be the largest perfect square you can find. So you're going to take the square root of the perfect square and you're going to leave what's left over under the radical symbol. So we're going to go through cases or examples of both cases. Whichever case you have, if there is a coefficient outside the radical, a number on the outside, like in example 3 here, I have a number 2. Or the coefficient 2 on the outside of my radical. We've got to multiply that with any number that gets to divide out of the radical. All right, let's go through these cases. Number 1 is a perfect square. 7 times 7 is 49. What really is happening, I'm going to do it maybe once or twice, but then we're not going to go through what it looks like. This is 7 to the second power. That's what you have to think of. What to the second power gets us that number. If it's a perfect square, you'll have an exact number. What's really happening is the square root and the square are opposite of each other and they cancel each other out. So what's left over is 7. Same thing's happening here. 15 squared is 225, so the square root and the square cancel, so I'm left with 15. I don't have to write this step. If I understand that 15 squared is 225, I know the answer is just going to be 15. I have a 2 on the outside. 12 squared is 144, so this is 2 times 12. What just happened? I'll do it one more time. This is 12 squared on the inside. The squared and the square root cancel. There's no symbol between them, so it's multiplication. So 2 times 12 is 24, so our answer is 24. Radicals can be over any kind of number, including fractions. Don't be scared if you have fractions. If you have a fraction, we're just going to think about it this way, where I have the square root of 4 over the square root of 9. Both of those are perfect squares. Square root of 4 is 2, square root of 9 is 3. The answer is 2/3. Same thing here. Square root of 1 over square root of 81. Square root of 1 is 1, because 1 times 1 is 1. Square root of 81 is 9. The answer is 1/9. Square root of 36 over square root of 121. We don't have to write this step if you understand that this means this step. So we could skip straight to knowing that this is 6 over 11. Now, those are the simpler ones. Those middle steps, that can be mental math. When we get to ones that are case 2, not necessarily mental math, and I want to see the factors. So you do have to show the factors of the radical. So when we're looking at 112 is not a perfect square. We want to divide it by the biggest perfect square possible. So you would take 112 and you divide it by 4. 4 and 28 work, but is there a bigger perfect square? 112 divided by 9. That gives me a decimal. 112 divided by 16. 16 and 7. We're going to pick those two. So this is really radical 16 times radical 7. Well, radical 16 is 4, and radical 7 stays radical 7, and that is our simplified radical. So that's what we're doing. We're trying to split the original radical into its factors when we're doing case 2, and we're simplifying the perfect square portion. So 245, well, 25 is the perfect square that ends in 5. 245 is not divisible by that, but it ends in 5, so it has to be divisible by 5. When you divide it by 5, 5 times 49, and 49 is our perfect square. So this is really radical 49 times radical 5. Radical 49 is 7, so we got 7 radical 5. Our next one, 5 times radical 72, 5 times radical 72, if I divide it by 2, that's 2 and 36. 36 is quite a big perfect square. 2 doesn't have any other factors. 5 times 6 times radical 2, so this would be 30 radical 2. In the end, we won't write the multiplication dots, but it's okay to put them in the middle so you remember that you're multiplying. Okay, I'm going to zoom out just for a second. And then we're going to finish the last 3, and then I will pause to ask if there are any questions. Okay, so we have this 9, 45. 45 is radical 9 times radical 5. 9 is a perfect square. 3 times 3 is 9. So 9 times 3 here is 27, radical 5. Next one, radical 250. 25 is a perfect square. We can divide. 25 times 10 is 250. So if I turn this into radical 25 times radical 10, this becomes 5 radical 10. Our next one, this 3 on the outside, 578. Just randomly, divided by 16, that doesn't work. Divided by 9, that doesn't work. Divided by 4, that doesn't work. Let's pick a big one. 144. No. Look at our list. Let's go back up to our list. Pick another. Let's go up the list. $289. 289 times 2. Radical 289 times radical 2. If you can't remember what radical 289 is, you put it in the calculator. That's 17 squared. So 3 times 17 is 51, so we get 51 radical 2. All right, I'm going to zoom out. Any questions about the steps of simplifying radicals before we now put it into solving equations?